Let us discuss the basics of inverse functions. Just the simplest things that everyone can be able to do without much problems. The basics of inverse functions. So we are particularly focusing on the graph of a quadratic function, which is a parabola. Let's say we have this graph given here. F of x is equal to x squared. And I want to determine the graph of the inverse of f of x is equal to x squared. Now, notice something here. Look at the shape of the graph. My graph is going upwards, which means my graph is facing the positive direction. It is going up, therefore it is going towards the positive direction of the y-axis. The inverse function must also go towards the positive direction. That is one characteristic that you can use to make sure that you get your graph right. If the original function is facing the positive side, the inverse is also going to face the positive side. That's how these graphs are connected. So without any coordinates, I can make a sketch of the inverse function because I know the shape of the graph. If the graph is facing the positive side, then the inverse is also facing the positive side. So right now, the graph in black is f, and the one in red is the inverse of the one in black. Let's have a look at a different equation. F of x is equal to negative x squared. Now, my graph is going towards the negative side. This is the negative, is going to the negative infinity. Now, the negative side of the x-axis is where the inverse is going to face. So my function is going towards the negative side. Therefore, the inverse must face the negative side as well. They must face same direction in terms of negative and positive. So this is my inverse function, and this is the graph of f. As simple as that. Let's have a look at the two put together. Let's have, right. I want to draw the inverse. This one is the first one that we have discussed. My graph is going to the positive direction. Therefore, the inverse must go to the positive direction. If your graph is going to the negative, the same thing applies. The inverse must face the negative. So that is my graph. For the second one, my graph must face the negative direction. My sketch is not very nice because of my pen here, but the idea must be clear. That is as far as the shape of the graph is concerned. I can use the shape of the graph to determine where the graph is supposed to be. Then when it comes to numbers, now we are talking about coordinates that are given on the graph. The coordinates, they swap. When you are determining the inverse function, coordinates xy will become yx. That is another important idea. The coordinates xy will become yx. I have put 2 points in the first graph here just for illustration purposes. The graph is passing through 0, 0. If you swap 0 and 0, the coordinates will remain 0 and 0. So it means my original function and the inverse are both passing through point 0, 0. The graph is passing through minus 2 and 4. If I swap minus 2 and 4, I get 4 and minus 2. So the graph is going to pass through 4 and minus 2. That is one of the points where the graph is going to pass through. The graph is passing through 2, 4. My inverse will pass through 4, 2. That is the graph and its inverse. If you are given coordinates on the graph, you swap the coordinates on the graph to get the coordinates of the inverse function. Then another important idea, which is very much critical, is to know that the graph of f and its inverse, they are a reflection of each other along the line y is equal to x. That is one critical idea. So f and the inverse of f and the inverse of f, these two are a reflection. They are a reflection of each other. They are a reflection of each other. Where they are a reflection of each other along the line or about the line y is equal to x. So if should they ask you, this is one important special relationship between a graph and its inverse. They are a reflection of each other along the line y is equal to x. So this is idea number 2. Remember how I started? The first one is that in terms of the sign, if the graph is going to the positive direction, the inverse will also go to the positive direction. Then if there are coordinates given, coordinates they interchange, xy will become yx. Then the third one is the domain and the domain and the range of the function. Let's look at the first graph that is here. Now, what is the domain of this graph? In general, the domain of a parabola is that it starts from negative infinity and it goes to positive infinity. Remember, domain means on the left to the right, from left to right. Where does the graph start and where does it end? So this one starts from negative infinity and it goes to positive infinity. Or we can simply say x is a real number. X is real. That is the domain of the parabola. The range of the parabola, the range is determined by where the graph starts. So in this case, my range will be y is an element of, the graph starts at 0 going up to positive infinity. That is the range of f. Please take note, these are the details of f. The graph of f of x is equal to x squared. So the domain, infinity to infinity. The range, 0 to infinity. And remember, the range will depend on where the graph starts, because range means bottom to top. At the bottom, where does the graph start? And on top, where does the graph end? This one starts at 0 and it ends to positive infinity. Therefore, the range is from 0 to infinity. Domain, where does the graph start? On the left, and where does it end? On the right. So therefore, this one starts from negative infinity and it goes to positive infinity. Now, what about the inverse function? What is the relationship between the domain of a function and the domain of the inverse? Now, the domain of a function can help you find out the range of the inverse. The domain of a function can give you the range of the inverse. The range of the function can give you the domain of the function. So how does that work out? Let's look at these two that I have here. The domain is infinity to infinity. That domain can give me the range of my inverse. So to get the range of the inverse from the domain of the function, you replace x in the domain of the function with y. If you replace x with y in the domain of the function, what you get there is the range of the function, which means the range of my inverse is y is an element of negative to positive infinity. In the same way, if you replace y in the range of the function with x, you get the domain of the inverse. So I want to write down the domain of my inverse. Then I can say that the domain will be x is an element of, in place of y in the range of the function, you put x. So what you get there becomes the domain of the inverse. So these are the details of my inverse. I can safely say that the range is from negative infinity up to positive infinity. The domain is from 0 up to positive infinity. Those are the details of my inverse as well as my original function. So it's very much vital for us to have a good understanding, a clear understanding of how this works, because definitely this is something that you expect to have in your examinations. All right, let's meet up in the next section when we discuss more information on the inverse functions. Let's quickly make sketches of the inverse functions for these graphs. Right, the first one starts from -4. Now, the inverse of a function, when you are constructing the inverse, the coordinates xy, they become yx. In simple terms, you swap the coordinates that are given. So this coordinate here is 2, 0. It means my inverse is going to pass through 0, 2. This is -2, 0. The inverse is going to pass through 0, -2. Then this coordinate is 0, -4. The inverse will pass through -4, 0. The x coordinates becomes the y coordinates, and the y coordinates becomes the x coordinates. Then from there, I can make a sketch of my function, touching through those points, going in that direction. This is the inverse. No, this one must be 2. This is the inverse of the given graph. I have drawn the inverse. If you remember what we said earlier on, the direction of the graph must be the same as the direction of the inverse in terms of their signs. So this one is going upwards. By upwards, I mean it is going to the positive side of the y-axis. The inverse must go to the positive side of the x-axis. That's how the two graphs are linked. The second one, in the same way, this point up here is 0, 4. It must become 4, 0. This point is -2, 0. It becomes 0, -2. Then this point is 2, 0. it becomes 0, 2. Now, which direction is the graph facing? The original function is going towards the negative side. So my inverse must face the negative side of the other axis, which means the inverse is going to go to the left side. That's where the x-axis is negative. So from 4 to negative 2, we draw a graph that passing through those points, and that point there, we also do the same thing going upwards. My line is not very cute, but that is my function. So this is the inverse, and the black one is the graph of f. So let's have a look at these ones on the right hand side. My graph is going to the positive side, therefore the inverse must go to the positive also. This is the inverse, the graph of the inverse. Now this point is not given. I moved numbers here deliberately. Let's say there is a here which is on the negative side. So this is negative. So the a will be on the negative side as well. Then from that point the graph goes. So from here the graph will go in that direction. This will be the graph of the inverse. This one, the graph is going to the negative side, so the inverse will go to the negative side. The graph is negative, is going to the negative side, but starting from a positive upwards point, the inverse will also be facing the same direction. This is how you draw the inverse graph. Just the basic, especially for those who are not doing well. This can be the easiest one to get marks from this section. Important for us is to highlight that the graph, the inverse of a parabola is not a function. This question, they ask it a lot. The inverse of a parabola is not a function. The inverse of a parabola is not a function. So if they say give a reason, the easiest reason to say to remember will be the graph fails a vertical line test. Remember, if you draw a vertical line across a graph and the line is crossing the graph 2 times, it follows that the graph is not a function. So therefore, the inverse of a parabola is not a function. It is not a function. It fails the vertical line test. The inverse of a parabola, the inverse of a quadratic function, is not a function. That's very much important to please take note of. You get questions that may say to you, is the inverse of the following a function or not? Justify your answer. The answer is no, it is not a function because it fails the vertical line test. So in this particular section, let's quickly talk about that. The question may ask you to restrict the domain of the function so that the inverse becomes a function. What does it mean? If a graph is drawn, let's say I've got this one here, f of x equals to x squared minus 4. The domain of this graph is from negative infinity to positive infinity. That is the domain of the function. Now, if we were to draw the inverse of this graph, we notice that, we remember when you are drawing the inverse, the coordinates swap. So 0 minus 4 will become 4 minus 4 0. Then the other 2 points I have, minus 2 0 will become 0 minus 2. So generally, if I draw the graph of the inverse, the graph is gonna be something like that. Roughly, this will be the graph of my inverse function. Now, this inverse is not a function. The parabola is a function, but the inverse is not a function because it fails the vertical line test. Now, if an instruction says to you, like this question that I have here, restrict the domain of f so that the inverse becomes a function. This is what it means, and this is what you do. The restriction that you write down as your answer, write down one restriction on the domain of f so that the inverse will become a function. The restriction will be x is an element of negative infinity up to p. This is the restriction. Then the other one will be x is an element of p up to positive infinity. You write both of them unless if you are requested otherwise. This is the restriction. In each case, p represents the x coordinate of the turning point. In place of p, you put the x coordinate of the turning point. So let's say I have this graph here that is indicated. If the graph is restricted and we draw the equation, the graph on a grid, for f of x is equal to x squared, the domain of this graph will be, if I say what is the domain here, if you look at this graph, you are going to see that the graph starts from the left hand side. It starts from the left, which is negative infinity, and it goes up to 0. This is the domain of the function. So instead of having a complete graph from left to right, I only have half of it, which means I have limited the domain from negative to positive infinity only to 0 from negative infinity. And my graph is now from the negative side up to 0.0. This is what we call a restricted domain. This is the graph of a domain that has been restricted. Now look at this. If we were to draw the inverse of this half in the same way, minus 0 minus 4 will become minus 4, 0. So let's say minus 4, 0 is somewhere on the x-axis. Then this is minus 2, 0. It will become 0 minus 2. Let's say it's somewhere here on the y-axis. Then if we draw the graph will be one piece from that side going like this. This will be the inverse of my function. Now if I ask you in the second graph, is this inverse a function? Yes, it is now a function because the domain has been limited. It is limited to 0 from the negative side. That is what we call restricting the domain. The other option is from p up to positive infinity. Remember, p represents the x coordinate of the turning point. If my domain is limited to the positive side, it means my graph is going to be in the green highlighted space, which is the right hand side from 0. So now in the third scenario, the domain for this function will be, the domain is from p, which is 0 up to positive infinity. The domain has been limited to 0 up to positive infinity. Remember, keep it the background of your mind that the domain of a parabola is from negative infinity to positive infinity. But in this case, our domain is from 0 up to positive infinity. We call that one a restricted domain. In examinations, you must be careful with this kind of questions because if you look at it from a distance, it will look like an exponential function. You have to look at the equation. The equation is the one that will tell you that this is a parabola whose domain has been restricted. If we want to draw the inverse of this graph, the graph of the inverse of the function, in the same way, it's going to start from -4. So -4 is on the left. This one is a 2, 0, which will become 0, 2. So my graph will be somewhere up here. Then from there, from this point, the graph will go up in that direction. This is the inverse of the function. The inverse is now a function because the domain has been limited. So in place of the word limited, we are using the word restricted. The question will say restrict the domain so that the inverse may become a function. This is exactly what we mean by that. So we may have to look at more examples on this one just to get clarity on what exactly it means to restrict the domain of a function so that the inverse becomes a function. The inverse of a parabola is not a function. Very much important for us to keep that in mind. The inverse of a parabola is not a function. However, we can make it a function by limiting the domain of the graph. We can make it a function by limiting the domain of the graph. Let's have a look at this question here. The graph of f of x is equal to minus x squared plus 4. Is the inverse of f a function? Motivate your answer. So for question number one, the answer is definitely no. The inverse of a parabola is not a function. So the simplest motivation we can give is that the graph fails the vertical line test. It is not a function because the graph fails the vertical line test. Then question number 2, restrict the domain of f so that the inverse of f becomes a function. This is the restriction that you must write all the time they give you this question. There are two options. You write both of them unless if the question specifies otherwise. So my restriction, which is the answer to number 2, will be x is an element of negative infinity up to p. Then you put brackets on the side of p, you put square brackets. Or x is an element of p up to positive infinity. This is the answer to this question all the time. In place of p, we put the x coordinate of the turning point. P represents the x coordinate of the turning point, which means the answer to this particular question now will be x is an element of negative infinity up to 0 because the x coordinate of the turning point at the bottom here is 0. You take the x value of the turning point. That is what you use in place of p. So the other option will be x is an element of p up to positive infinity. This is my answer. That is what we call a restricted domain of the function. In some examination questions, they may ask you to draw the graph of the restricted domain. And if they do, they will specify which one of the two you must draw. If they don't, then it means you may have to draw both of them. So this is how my graph will look like if the domain is restricted. Let's start with the first one. X is an element of negative infinity up to 0. It means my graph will start at 0, which is at 0, -9. Then go to the left side. So which means the curve is just going to be a piece of it from 0, 9 going to the left hand side. This will be my graph if the inverse is restricted. The other option, which is from P to positive infinity, it means my graph starts from 0, 9 going upwards. So from 0, 9 I go up in that direction. That will be my inverse. That will be my graph of f after the domain has been limited. So in the first one, if I want to say, okay, what is the domain here? For this one, the domain is, the graph starts from 0, so x will be, it starts from -infinity, it starts on the left and it ends at 0. Remember, domain means from left to right. Where does the graph start and where does it end? For this one, the domain is from 0 going to the right hand side. The domain has been limited, or the domain has been restricted. And if the domain is restricted, then the inverse will become a function. Now, if we want to draw the inverse of the restricted graph, or for the graph whose domain has been restricted, then this one will start this point here. If this one is -9, then this one will also be -9. Then from here we draw a curve. We draw a curve that goes in that direction. This will be the inverse of my function. Then in this one, this is -9. The graph is going in that direction. So the graph will also start at -9 on the x-axis. Then it will be a curve going in that direction. This will be my inverse of the function. So basically what we are saying here is that if you are restricting a graph, you are drawing half of the graph. My graphs are not very smooth, I'm sorry, but the idea is what you need to make sure you understand. Then lastly, what is the relationship between a graph and its inverse? Now we can say the inverse function is a reflection. This is a reflection. The inverse is the reflection of f along the line. This is the reflection of f along the line y is equal to x. And this reflection is done by swapping coordinates. xy becomes yx. That is the relationship between them. Should we want to really have a look at the two, how they relate put together, we can simply draw a line across. The line y is equal to x is the line that passes through 1, 1, 2, 2, 3, 3, 4, 4, 0, 0 in that direction. This will be my line y is equal to x. So if I reflect this point, it will come to that point. If I reflect this -9, it will go to that -9. Then we can say the graphs are reflected along the line y is equal to x. That is the inverse function, general ideas, basic ideas about the inverse